Alright, so today we're going to be solving the problem 2sum. So let's start by reading the question. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. So let's highlight this part. And also, you can return the answer in any order. So let's try to solve this problem using example 2. So we're given an array with element 3, 2, and 4, and the target is 6. So we'd start by looking at the first element in the array, which is 3, and try to find its corresponding value. Its corresponding value should be 6, the target, minus 3, our currently pointed value, which is 3. And we would search through the array for this other 3. So we'd look at 2, so it's not 3. We check for 4, and it's also not 3. So we know the first element cannot be one of the numbers in our answer. So now we would go to the next number and try to find its corresponding number. So we do the same step, 6 the target, minus 2 the currently pointed value, which is 4. And now we look for 4. So we see next to 2 there's the 4. So that means we have found the answer. So we are asked to return the index of each of these numbers. So this one has index 1 and this one has index 2. Therefore, you should be returning an array containing the index 1 and 2. So let's try to calculate the time complexity of this solution. So we know that we start by pointing at the first value in the array, and we'd search for its corresponding value. So to find a corresponding value, we'd go to the element directly next to it, and then iterate one by one until the end. So for an array of size n, this took n minus 1 steps. So we'd be repeating this process for every element in the array. So now we're pointing at B and looking for its corresponding value. So we'd go to C, D, E, F, and G, and this would take now n minus 2 steps. So we'll be repeating these steps until we reach the element before the last. So in this case, it's F. And to find its corresponding value, there's only one option left. So to count the total number of steps, we started with n minus 1, and then n minus 2, and then all the way up to 1. So as we can see, this is a summation from 1 to n minus 1. So the equation to find the total number of steps would be n minus 1 times n over 2, which is equal to n squared minus n over 2. So we can see the time complexity is O of n squared. So as you can see, the bottleneck of this solution is finding the corresponding value, since we're iterating through the rest of the array. So taking n minus 1 steps for the first element and n minus 2 steps for the second element, and etc. up till 1. What if we could do it in one step? So this can be accomplished using the map data structure. So a map has a key, and that key is related to a value. So if we use the map where for each element, so here we'd have A has the value 0, which is its index, B has its value 1, C has the value 2, and etc. If we were looking, let's say, for the element C, then we'd be using the key C, and then we'd get the value 2. And this operation is of time complexity O of 1. So with this new method, we'd have to iterate to each element in the array. And for each element, we'd be looking for its corresponding value. So the time complexity of iterating through the array is of O of n. And for each one of them, we're looking for its corresponding value, which is now O of 1, which with the map data structure. So the new time complexity is O of n, which is better than the previous time complexity of O of n squared. So we'll start by instantiating our hash map, which has an integer as a key and an integer as the value, because the key is a number inside the array and the value is an index. So then we'll be going through our array and populating our hash map. Now we'll loop through our nums array again. We'll define the corresponding value. So the corresponding value is the target minus the number at the current index. And the corresponding index we will get from the map. So here we're using the integer wrapper class because the corresponding index could be null if the corresponding value doesn't exist in the map. So now we'll be checking if the corresponding index isn't equal to the current index, because as mentioned in the question, you may not use the same element twice. And we're also checking that it is not null, meaning that it exists. So if these two conditions are satisfied, then we can return the answer, which is an array of the two indices, the index of our currently pointing number and the index of the corresponding value. So let's test out our code. So seems like I forgot my return statement at the end, although we know that it'll return in the loop. We'll return null at the end just to make the Java compiler happy. And hooray, it works.